Hello friends, myself Satyajit Nandi. Welcome to my YouTube channel. In today's video, we will discuss the miscellaneous of chapter 2. That is inverse trigonometric function. Now there are 17 problems and we will solve the 14 problems of miscellaneous. Number 1, you are given find the value of the following: cos inverse of 13 pi by 6. Number 1, cos inverse of 13 pi by 6. Now first of all, we must remember the inverse of cos function has range 0 comma pi, that is in first and second quadrant. Now after cos inverse and cos getting cancelled, the value of the angle, the radian value must lie in this interval. Now if I normally omit cos inverse and cos, I will get 13 pi by 6, which is more than twice pi, which is not correct. Now you see, we can write cos inverse of this is twice pi plus pi by 6. We know in first quadrant cos theta is positive. Cos 2 pi plus theta is equal to cos theta. Therefore, you can use this cos inverse of cos pi by 6. Now, cos inverse and cos get cancelled. Your value will be pi by 6. This is your result. Number 2, find the value of tan inverse of 7 pi by 6. 7 pi by 6. This angle 7 pi by 6 is greater than pi. That is, this angle lying in third quadrant. In third quadrant, tan is negative. Positive. We know the principal value of tan inverse of x is equal to lying between minus pi by 2 to plus pi by 2 open interval. Now, since tan inverse is positive in first quadrant and third quadrant, we can write this tan inverse of tan of pi plus pi by 6. Tan inverse of this is tan pi plus theta is tan theta. Tan pi by 6. Tan inverse gets cancelled. Result is pi by 6. This is your required value. This value pi by 6 lie in the principal value of tan inverse of x. This is your solution. Now we will apply the given formulae. Number 3, you are asked to prove that twice sin inverse of 3 by 5 is equal to tan inverse of 24 by 7. So it is given twice sin inverse of x, but we don't have any formula like this. Twice sin inverse of x is equal to tan inverse of anything. There is no such formula. How to find this? Now we will apply geometry. LHS is equal to twice sine inverse of 3 by 5. So 2 times the corresponding angle for which sin theta attains 3 by 5. If I let sin inverse of 3 by 5 is equal to theta. Theta is positive because 3 by 5 is positive. Sin theta is positive in first quadrant and negative in fourth quadrant. This is 3 by 5 is equal to sin theta, right? From class 11's trigonometric concept, what is sin theta? Perpendicular by hypotenuse. This is 3 by 5. This is your theta. Perpendicular hypotenuse base. If it is 3, if it is 5, you can say definitely it is 4 because 3, 4, 5 they form a Pythagorean triplet. This is sin theta. Now, if I find tan theta, what is tan theta? Tan theta will be is equal to 3 by 4, perpendicular by base. This is equal to 3 by 4. That means theta is equal to tan inverse of, I can write this angle in terms of tan inverse. This is equal to 3 by 4. Therefore, your LHS becomes twice tan inverse of 3 by 4. Now we can convert 2 tan inverse of x in terms of tan again. We know twice tan inverse of x is equal to tan inverse of twice x by 1 minus x square. Use this, we will get 2 times this is equal to tan inverse of twice x divided by 1 minus 3 by 4 whole square. After simplification, you will get tan inverse of 24 by 7. This is your required proof. Now, question number 4. You have to prove that sin inverse of number 4, you have to prove that sin inverse of 8 by 17, sin inverse of 3 by 5 is equal to tan inverse of 77 by 36. Now, how to find this? Write LHS, you will get sin inverse of 8 by 17 plus sin inverse of 3 by 5. Sin inverse of 8 by 17 and tan inverse of 3 by 5, they both represent two angles in terms of radian. Now, how to find the required value tan inverse 17 by 36? Let alpha is equal to sin inverse of 8 by 17 and beta equals to sin inverse of 3 by 5. That means sin alpha denotes 8 by 17 and this is sin beta denotes 3 by 5. Now draw two triangles. Using Pythagorean triplet method, we will find that what is sin theta? Perpendicular by hypotenuse. This is 8, this is 17, this is 3, this is 5, definitely it is 4, and this is for 17 square it is 289, this is 15, this is 64, 64 plus 225, 289, 17 square, that is your LHS I can write the LHS. I can write the LHS in terms of tan inverse. What is tan theta? Perpendicular by base. I can represent sin inverse in terms of tan. It will be is equal to 8 by 15, and this is tan inverse of 3 by 4. Now, the product of 8 by 15 and 3 by 4 is less than 1. 3 8s are 24, 4 15s are 60. This is less than 1. We can use the property tan inverse of x plus tan inverse of y is equal to tan inverse of x plus y divided by 1 minus xy. Hence, your answer will be 8 by 15 plus 3 by 4, 1 minus 8 by 15, 3 by 4. Now calculate and you will get the solution to be 77 by 36. 4 8s are 32 plus 45, this is 77, minus 45 minus 60 minus 24, this is 36. You got the solution. This is your number 4. Now proceed for question number 5. Now proceed for question number 5. You are given, prove that cos inverse of 4 by 5 plus cos inverse of 12 by 13 is equal to cos inverse of 33 by 65. You can directly apply the formula of cos inverse of x plus cos inverse of y is equal to cos inverse of xy minus square root of 1 minus x square into square root of 1 minus y square. You can apply this also, or you convert it into tan inverse, and then from tan inverse you convert it into cos inverse. Let us apply this. If I apply this, LHS will be cos inverse of 4 by 5 cos inverse of 12 by 13. If I apply this property, I will get 4 by 5 into 12 by 13 minus square root of 1 minus 4 by 5 square into square root of 1 minus 12 by 13 square. Cos inverse of this is 48 by 65. After calculation, this is equal to 3 by 5. This is 4 by 13. That is cos inverse of 48 minus 12 by 65. Hence, your result is cos inverse of 36 by 65. This is your required 30. So this is 5. Sorry, this is 5. This is 15. 33 by 65. This is your number 6. 5. Now, what about number 6? Number 6 is cos inverse 12 by 13 plus sin inverse 3 by 5 is equal to 36 sin inverse 56 by 65. Number 6, you are given cos inverse of 12 by 13 plus sin inverse of 3 by 5 is equal to sin inverse of 56 by 65. Now, how to solve it? Similar question, the result is in sin inverse of x. This is cos inverse, sin inverse. You can apply the formula of sin inverse x plus sin inverse y, but it is cos inverse. At first, let cos inverse of 12 by 13 plus sin inverse of 3 by 5 is equal to LHS. Now, let theta is equal to cos inverse of 12 by 13, that is cos theta equals 12 by 13. Apply Pythagorean geometry, you will get, what is cos? Base by hypotenuse. This is 5 because 5, 12 and 13 forms a Pythagorean triplet. Therefore, we can write this cos theta is equal to sin theta 5 by 12. This cos theta equal to 12 by 13 and sin theta is equal to 5 by 13. If I take their inverse, they will represent a same angle. So, I can write this as sin inverse of 5 by 12 plus sin inverse of 3 by 5. Now, apply sin inverse x plus sin inverse y is equal to sin inverse of x into square root of 1 minus y square plus y into square root of 1 minus x square. After calculation, you will get the result is equals to 56 by 65. This is number 6. Number 7 can be solved like question number 4. Convert it to in tan inverse of x and then from right side you find the left side. What about question number 8? You have to prove that tan inverse of 1 by 5, number 8, tan inverse of 1 by 5 plus tan inverse of 1 by 7 plus tan inverse of 1 by 3 plus tan inverse of 1 by 8 equal to pi by 4. Calculate this. Sum of 4 acute angles is equal to another acute angle pi by 4. Now calculate this. So LHS, there are how many tan inverse? 4. Now I can write tan inverse of 1 by 5 plus tan inverse of 1 by 8 plus tan inverse of 1 by 3 plus tan inverse of 1 by 7. Why I arranged these inverse functions like this? You will get to know the required arrangement after this step. This is tan inverse of 1 by 5 plus 1 tan inverse 1 by 8. Find their product, it is less than 1. We can apply tan inverse of 1 by 5 plus 1 by 8, 1 minus 1 by 5 into 1 by 8. Similarly, tan inverse of 1 by 3 plus 1 by 7, 1 minus 1 by 3 into 1 by 7. This is tan inverse. Take LCM. This is 8 plus 5. This is 40 minus 1. And this is tan inverse of 7 plus 3. This is 21 minus 1. Now tan inverse of 8 plus 5, 13 and 40 minus 1, 39. Now if you divide this 1 by 3 and this is tan inverse of 10 by 20, 1 by 2. Again apply tan inverse of x plus tan inverse of y, will get 1 by 3 plus 1 by 2, 1 minus 1 by 3 into 1 by 2. Result will be tan inverse of 2 plus 3, 5, this is 6 minus 1. Hence, the result is tan inverse of 1. This is pi by 4, which is my required solution. This is question number 8. Now, question number 9. Number 9, it is given, prove that tan inverse of square root of x is equal to half into cos inverse of 1 minus x by 1 plus x, where x belongs to 0, 1, 0, 1, close that one, 0. You are given tan inverse of root over x is equal to half times cos inverse of 1 minus x by 1 plus x. So, we will start from the right side. RHS is equal to half into cos inverse of 1 minus x by 1 plus x. We can use substitution method. Why this? Because cos inverse of 1 minus tan, you can write cos twice a is equal to 1 minus tan square theta by 1 plus tan square theta. So, if I put x equal to tan square theta, we will get half into cos inverse of 1 minus tan square theta divided by 1 plus tan square theta. This is equal to half into cos inverse of cos twice theta. Now, this cos inverse and cos getting cancelled. It will be half into twice theta. 2 cancelled, you are left with theta. What is theta? We know tan square theta is equal to x. Therefore, tan theta is equal to square root of x. Hence, theta is equal to tan inverse of root over x. X belongs to 0, 1, which is positive, hence it is not undefined. It is defined on the interval 0, 1. This is your required solution, LHS. Number 10. Number 10 can be solved in two different ways. Today I will show you both ways. Number 10, you have to prove that cot inverse of square root of 1 plus sin x minus plus square root of 1 minus sin x divided by square root of 1 plus sin x minus square root of 1 minus sin x. You are given x is equal to pi x by 2, where x belongs to 0, pi by 4. 0, pi by 4. If in the first solution you will not get the significance of this interval. First solution, LHS, cot inverse of square root of 1 plus sin x plus square root of 1 minus sin x divided by square root of 1 plus sin x minus square root of 1 minus sin x. Now, if I rationalize this, will get cos inverse of root over of 1 plus sin x plus root over of 1 minus sin x whole square, and this is square root of 1 plus sin x whole square minus square root of 1 minus sin x whole square. Rationalize this, you get cot inverse of, what is a plus b whole square? A square 1 plus sin x, b square 1 minus sin x plus twice ab, product of square root of 1 plus sin x into square root of 1 minus sin x. A plus b into a minus b, you will get a square minus b square, a square minus b square, a plus b into a minus b, a square minus b square. After squaring, you will get 1 plus sin x minus 1 minus sin x, cot inverse of 1 plus sin x, 1 minus sin x, sin cancelled, 1 plus 1, this is 2, 1 minus sin square is cos square, take square root, this is cos x, again 1 cancel, minus minus plus, this is twice sin x. Now, if I cancel 2 and 2 in the numerator and denominator, I will get cot inverse of 1 plus cos x divided by sin x. Now, use the property of submultiple angles, you will get cot inverse of 2 cos square x by 2, and for sin x twice sin x by 2 multiplied by cos x by 2. This is 2 cancel, cos square cancelled, left with 1. This is cot inverse of, what is cos by sin? Cot x by 2. Hence your solution is x by 2. This is your solution. This is solution 1. Now solution 2. This is your solution 1. Now solution 2. Second solution, how to write this. What is 1 plus sin x? If you notice, what is 1 plus sin twice x? 1 plus sin twice x can be expressed as cos x minus sin x plus sin x whole square. 1 plus sin twice x is cos x plus sin x whole square. We can write this as cos x plus sin x whole square. Hence, I can write this, cot inverse of square root of cos x by 2 plus sin x by 2 whole square plus square root of cos x by 2 minus sin x by 2 whole square. Now the question arises, if you take square root of a plus b whole square, where both a and b are positive, then where a and b both are positive, then it will be a plus b, correct? But if it is a minus b whole square, square root a and b both are positive, then how to write this? Then you must write mod of a minus b. Why a minus b mod? Because after square root, the value of the square root cannot be negative. You have to write mod of a minus b. Now, if a is larger than b, then you can write a minus b or b minus a. Here, I have written this is cos x by 2 minus sin x by 2. Why a minus b whole square? Because cos is larger in the interval 0 comma pi by 4. If you see carefully, if I draw the graphs of cos x and sin x, you will notice that the graph of cos x is this, so sin x is this, and for cos x it is this. This is 0 comma pi by 4. In this interval, the graph of cos x is lying above sin x. That is why cos x is larger here. Hence, sin x is smaller. That is why I have written a minus b whole square, where cos x by 2 is larger than sin x by 2 in the interval 0 comma pi by 4. Now you are getting the significance of this interval given in the question. Similarly, in the denominator you can write cos x by 2 plus sin x by 2 whole square minus cos x by 2 minus sin x by 2 whole square. After square root it becomes cos x by 2 plus sin x by 2 plus cos x by 2 minus sin x by 2 divided by cos x by 2 plus sin x by 2 minus cos x by 2 minus sin x by 2. See, plus sin minus sin cancel, this is twice cos x by 2, and minus cos plus cos cancel, this is twice sin x by 2. 2 cancel, cot inverse of cot x by 2. Cot inverse cancel, answer is x by 2. This is your required proof. This is question number 10. Now move on to question number 11. 11. This is, you have to prove that tan inverse of square root of 1 plus x minus square root of 1 minus x divided by square root of 1 plus x plus square root of 1 minus x is equal to pi by 4 minus half of cos inverse of x. You are given some conditions. You are given that minus 1 by root 2 less than x less than 1. Less than 1. You are given a hint. Put x equal to cos twice theta. Okay, let's start. LHS tan inverse of 1 plus x 1 minus x divided by root over of 1 plus x root over of 1 minus x. We are given the hint. Put x equal to cos twice theta. X equal to cos twice theta. Tan inverse of 1 plus cos twice theta 1 minus cos twice theta. This is root over of 1 plus cos twice theta plus root over of 1 minus cos twice theta. Tan inverse. What is 1 plus cos twice a? This is root over of twice cos square theta minus root over of 1 minus cos twice a root over of twice sin square theta, and this is twice cos square theta plus twice sin square theta. Now tan inverse of this is 2 root 2 root 2 root 2 root 2 cancelled, and after square root it becomes cos theta minus sin theta cos theta plus sin theta. Now simplify this. If I divide the numerator and denominator by cos theta, we will get tan inverse of cos by cos 1 sin by cos tan again 1 plus tan theta. Now proceed. What is 1? 1 is actually tan pi by 4. This is pi by 4 and this is tan theta. 1 plus tan pi by 4 into tan theta. Now tan inverse of this is tan A minus B divided by 1 plus tan A tan B, tan A minus B, pi by 4 minus theta. Tan inverse cancelled. This is pi by 4 minus theta. What is theta? You are given that cos twice theta is equal to x. That means twice theta is equal to cos inverse of x. Hence theta is equal to half of cos inverse of x. This is your solution. Now question number 12. This problem have another solution too. If you multiply by the conjugate of 1 plus x root over minus root over of 1 minus x in the numerator and denominator, that is, if I rationalize, you can simplify the question. Now question number 12. Prove that number 12, prove that 9 pi by 4, 9 pi by 8, 9 pi by 8 minus 9 by 4 sin inverse of 1 by 3 equals to 9 by 4 sin inverse of 2 by 3. LHS This is 9 pi by 8 minus 9 by 4 sin inverse of 1 by 3. This is 9, this is 9, 8 and 4. If I take 9 by 4 common, I will get pi by 2 sin inverse of 1 by 3. These questions are simple. If you practice 1 or 2 times, you can easily solve in the exams. 9 by 4. What is 90 minus sin inverse of x? This is cos inverse of x from properties of inverse function. We know that sin inverse of x plus cos inverse of x equals to pi by 2. Now, cos inverse of 1 by 3. We need the solution in terms of sine. Now, again, let alpha is equal to cos inverse of 1 by 3. That is, cos alpha is equal to 1 by 3. Alpha. What is cos theta? Base by hypotenuse. If it is 1, if it is 3, this is clearly 2 root 2. 2 root 2 square, 8 plus 1, 9. 9 is 3 square. Now, if I express sin alpha, it will be 2 root 2 perpendicular by hypotenuse. Therefore, this is 9 by 4. This is sin inverse of 2 root 2 by 3. This is your required proof. Now, solve the following. Solve the following. Number 13. Find the value of x. Twice tan inverse of cos x is equal to tan inverse of twice cosec x. Twice tan inverse of x has a property tan inverse of twice x by 1 minus x square. You can write this is equal to tan inverse of twice x 1 minus cos square x. This is tan inverse of 2 by sin x. Now, tan inverse and tan inverse cancelled. This is twice cos x by sin square x, 2 by sin x. 2 and 2 cancel. This is sin, this is sin x. If I cancel this, I have to write here x not equal to 0. For x equal to 0, this is 0, this is 0. So, if you cancel sin and sin the both sides, you must write x not equal to 0. Now, we are getting cos by sin, it is cot x is equal to 1. Now, the value of x for which cot is equal to 1 is equal to pi by 4. You can write cot x equal to cot pi by 4. Hence, your x equal to pi by 4. Number 14. Tan inverse of 1 minus x by 1 plus x is equal to half of tan inverse of x. You are given a condition x is positive. X is positive. Now, let us solve it. This is a very simple question. If I apply the property of tan inverse x minus tan inverse y, we will get this is equal to tan inverse of 1 minus tan inverse of x Hope you get the property. Tan inverse of x minus tan inverse of y. Now this is half of tan inverse of x. This is pi by 4 minus tan inverse of x is equal to half times tan inverse of x. Now multiply by 2, you will get pi by 2 minus twice tan inverse of x, again tan inverse of x. After calculation, you will get thrice tan inverse of x is equal to pi by 2. Tan inverse of x is equal to pi by 6, that is x equal to tan pi by 6. Tan pi by 6 is 1 by root 3, which is positive. This is my required solution. I hope we can solve number 15, number 16 and number 17. In next video, we will discuss some extra problems of inverse trigonometric function. And if you like my video, please subscribe my channel and share my video.